President Trump keeps talking about how we're fighting an invisible enemy. That's what he calls the COVID-19 virus. Of course, it's plenty visible. It's just really small. And I want to explain how it is we're able to see it. But first, we need to talk a little bit about how magnification works. And I also want to show you how to make your own cell phone microscope. This is something you can do at home if you have just one or two pretty cheap parts around. Now it's time to talk about visible light, and it's probably going to take a few videos to get through visible light, and then I'm thinking a couple of videos for X-rays. I have no idea what I'm going to do about gamma rays, and then maybe we'll circle back and do another one about radio and microwaves. But right now we're starting to talk about visible light, and one of the key things about infrared radiation is that if it moves from an area with one speed of light, say 300 million meters per second, to an area with a different speed of light, in this case something that's almost half as fast, so 150 million meters per second. When that happens, when the light goes through the interface between the two media, the light is bent, it's refracted. So the light comes in, when it hits the interface, it bends, and then you can't see it here, but when it gets to the other side of the interface, it gets bent again and ends up going back roughly in the direction that it started in, but offset by this much. So that is the phenomenon of refraction. We looked at refractive index, N, and we saw that the sine of theta 1 equals n times the sine of theta 2. Now, we're not going to do any math here. I just want you thinking about how when light hits different materials, it gets bent. And one of the things that we can do with refraction is use it to magnify things or to change the way things look through a material. And if you happen to wear glasses or contacts, that's exactly what's happening with your glasses or contacts. So let's go on here. We're going to make something that we can use to take magnified pictures with our cell phone. We just reviewed the concept of refractive index because we're going to be using the lens out of a cheap laser pointer to make a tiny magnifying glass that we're going to put in front of our cell phone camera. And this is exactly what we're looking for. On the left is the laser diode, and on the right is the laser pointer lens. We're going to take one of those things out. That picture of my fingerprint at the beginning of this video was taken using the thing that we're going to build. It's pretty easy to find instructions on the internet to make something so you can take your own pictures like that. And most of them involve cheap laser pointers like this. This one stopped working, so of course we're going to take it apart. I'm going to take the batteries out. We're not going to throw these in the trash, and that's probably why it quit working, because that battery leaked a little bit. On the other end, we can unscrew this cover here. And I had to work at it a little bit, and then I put it back together loosely so I could show you, but that just slides out. This laser module here just slides out of the tube. And I loosened it up with a screwdriver, but this black piece of plastic here actually unscrews pretty easily. And inside, inside, just like the internet promised, there is a little lens. So let's make a thing to hold this lens, and then we'll try taking some pictures through it. So here I am drilling a hole in a popsicle stick that is just the right size. Actually, I lied. I had to work at it just a little bit more to get the hole to be the right size, but now it is the right size that I can just press the lens in there. And now I'm going to attach this to the phone with a rubber band and take some pictures. This is the general setup. Of course, you need to line the lens and the popsicle stick up pretty closely with the lens in the cell phone. It would probably work better if I took my cell phone case off so the two lenses could be right next to each other, but it doesn't seem to matter which side of the laser pointer lens is facing the camera. So let's look at some pictures. This is a square on my graph paper. This square is 5 millimeters on a side, half a centimeter on a side. What is that, 1/4 inch maybe? This is another laser pointer I took apart, but I couldn't get at the lens. It quit working because of all that corrosion. And this is the skin on the back of my hand, and it's pretty obvious why you need to wash your hands for 20 seconds. It's pretty easy to carry this thing around, and I went outside and found a cool-looking lichen on a tree. That distortion around the edges there is called spherical aberration, and it's a pretty common characteristic with the type of lens we're using. The lens we're using is called a plano-convex lens. So that's it for building your cell phone microscope. Next, we're going to look at some real light microscopes, and then we're going to talk about how electron microscopes work.